Good time of day to everyone, and I would like to thank organizers for providing me this opportunity to provide a talk here, and also thank for organizing this session, because support of Ukraine is very important to us, and it remains important after more than a year of this full-scale aggression. And with this, I would like to go to my talk, which is related to physicochemical properties of fluorinated saturated heterocycles. Of course, I don't have to explain you the exceptional role of fluorine to medicinal chemistry, to drug discovery. What I would like to stress out that we have focused in these works on the PK and LogP, and occasionally on some other properties and impact of fluorine on them. And we have turned our attention to saturated heterocyclic and carbocyclic systems, because they appear to be gain much attention in medicinal chemistry, whereas the fluorine in drugs is usually encountered in aromatic systems where it is much more studied. In this review cited here, you can read about fluorinated cycloalkyl building blocks and their impact on medicinal chemistry in other areas, and also there's synthetic approaches to them. Some data on the impact of fluorine in saturated systems, of course, was available before our studies, and I would like to cite here most important works of Müller and co-workers, as well as Bidklaw and co-workers, related to fluorination of acyclic derivatives, and they established the impact of fluorine on both PK and LogP for these systems. And there were also works from the same groups on saturated cyclic systems, and also it is needed to be mentioned. The works by Hagen and co-workers are needed to be mentioned on the fluorinated cycloalkanes, viscally fluorinated cycloalkanes, so-called facially polarized cycloalkanes. Biatinamine had a serious advantage. We had an access to a huge number of common fluorinated derivatives of common saturated heterocyclic and carbocyclic rings, or possibility to synthesize them quickly. So we have aimed to measure physicochemical properties for these compound series, and so far we have succeeded with 4 compound classes in this area. These are fluoralkyl substituted saturated heterocyclic amines, mono and difluorinated saturated heterocyclic amines, functionalized fluoralkyl substituted small ring derivatives, and functionalized difluorinated cycloalkanes. Of course, I'm not able to cover all of them in this talk. I will stop only on the first 2 of them. If you are interested in this research, you can visit my webpage, Grigorenko.com, as well as Inamine page, Inamine.net, where these publications are cited, and you can read about them more. This, I shall start with fluoralkyl substituted saturated heterocyclic amines. So we have studied this compound series shown on the slide, and also added here to the set the corresponding non-fluorinated counterparts, as well as acyclic counterparts, to see the impact of both ring and fluorinated substituent on the physicochemical properties. So PK titrations were done with using usual acid-base titration of the parent compounds or the corresponding hydrochlorides. And you can see here that addition of fluorinated substituent has almost linear effect on the PK on the in terms of number of fluorinated atoms. Indeed, ring size didn't have significant impact for all these series. For the fluorination pattern, we could derive simple rule of thumbs that depend on the number of fluorine atoms and the position of the fluorinated substituent. There was some interesting effect of conformational restriction So that is addition of the ring system. But it also could be easily rationalized through inductive effect of the fluorine atoms, and because in ring system you have two pathways to pass the electronic effect of fluorine to the basic state. Therefore, decrease of basicity is larger for the cyclic compounds due to fluorination, which is compensated, of course, by the primary versus secondary amine modification. As for lipophilicity, the effects were not so obvious here, but in general, you can see that addition of fluorinated substituent usually increased lipophilicity. By the way, we measured lipophilicity by standard shake-flex methods. Therefore, in this case, we used benzoylated derivatives so that to make detection by HPLC more easy. Indeed, you can see that as for the ring size, the addition of each carbon atom should increase the lipophilicity. That was the case for alpha isomers and for most other compounds, but not always, because relative orientation of dipole moments should be also taken into account here. And so the effects were clearly non-linear. As for the fluorination pattern, you can see from this representation that indeed adding each fluorine atom it does increase lipophilicity, but the effect is strongest for the first and especially for the third fluorine atom. For the CH2F2 substituent, it is not so obvious. And indeed, in our further studies where we have studied cyclic alkane derivatives, we have shown that perfluorinated fluorinated substituent can even increase hydrophilicity, so delta LogP can be negative. In this series, there was only one such case, only one such example. And finally, as for comparison of cyclic and acyclic compounds, we couldn't derive any obvious regularities here, so the effects were quite complex. Quite interesting representation is obtained when we of our results is obtained when we depict our data in LogP-PK plot. These plots are quite similar to the classical Craig plots in medicinal chemistry, in early medicinal chemistry, where LogP was compared with biological activity and some other physicochemical properties. Here you can see that the compound series that we studied provide quite huge range of possibilities of modification for both PK and LogP. And this plot can even provide some rationale for substitution of the corresponding fluorinated ring systems. You can find here compounds which are quite close in structure, but different biophysical chemical properties, and vice versa. Compounds, for example, like this pair or this one, which have quite close physicochemical parameters, but very different chemical structure, vice versa. So these results can be indeed interesting for biostatic replacements for using these fluorinated series, for example. The second series that we have studied includes mono and defluorinated derivatives of the same heterocyclic amines, azitidine, pyrrolidine, piperidine. In this case, we needed to synthesize some of them, and for example, 3,4-difluoropyridine derivatives were synthesized from epoxide 1, using quite an interesting effect, which was observed for the 3 substituted pyrrolidine derivatives. That is participation of nitrogen lone pair at the deoxyfluorination step, which results in retention of the compound stereochemistry at this position. For the first position, for example, inversion configuration is observed typically, and this allowed us easily to obtain both diastereoisomers cis and trans quite easily in gram quantities. Also, I would like to draw your attention to the preference of the fluorine atom at the third position for axial orientation for both isomers here and here. It is quite typical for the three fluorinated piperidine derivatives in protonated or benzoylated, for example, acylated form. But this has quite interesting impact on their physicochemical properties, which I would like to present you just in the following slides. So as for PK, you can see from this diagram and from the following description that, of course, fluorine atom decreases the compound basicity by approximately 2 units, but the range is not very narrow, from 1.5 to 2.5 units. I would say, sorry. And position of the fluorine atom, I mean axial or equatorial, has some impact on the PK. It was known in the literature, of course, for similar systems, but we confirmed it here. So again, if the fluorine atom is at axial position, there is some stabilization of the protonated form, and this results in somewhat lower impact on the PK, about 2 points decrease. For the equatorial orientation at the same position, we have 2.5 decrease. And this is clearly seen, for example, for cis and trans 3,5 difluorinated derivatives, where trans isomer is significantly, considerably less basic. As for the LogP, again, we have quite complex strength here, but they can be generalized as follows. So addition 1 fluorine atom typically always decreased LogP, and the decrease might be quite considerable. But while addition, the second one, makes compound even more lipophilic than non-fluorinated derivatives. This trend is observed only for saturated heterocyclic amines, in particular for cycloalkanes derivatives, which have studied in other part of our work. This is not so easily. This is not so general. Fluorination at 2 different positions typically make compounds more hydrophilic, but not so hydrophilic as monofluorinated derivatives, with some exception, of course. The effect of the increased hydrophilicity of monofluorinated derivatives can be explained by structure shown in section B here. It includes polarization, but taking into account polarization not only of CF bond, but also by of adjacent CH bond, which makes compound more polar. As for different fluorination patterns, and the more symmetric is compound, the lower is its hydrophilicity, so its LogP becomes higher. And this was confirmed in most cases by us. And very interesting effect was observed for this isomer of 3,5 difluoropiperidine derivative, likely due to the actual orientation of both fluorine atoms. This compound is very hydrophilic. It is more 0.8 units of LogP more hydrophilic than the non-fluorinated compound corresponding. And this is quite similar to what O'Hagan and co-workers observed for the corresponding cycloalkane series, so-called Janus facial polarization. So this piperidine can be also called Janus phase piperidine. As for the combined LogP-PK plot, including both mono and defluorinated, as well as fluoroalkyl substituted derivatives of saturated heterocyclic amines, you can see here that mono and difluorinated derivatives complement other fluorinated compounds that were studied in our previous work. And the intersection between them in terms of physical-chemical properties is not so huge. So indeed, these fluorinated compounds as a whole set is reasonable to use for optimization of physical-chemical properties or interaction with biological target when physical-chemical properties are likely to be retained. As I mentioned in the starting part of my presentation, we also done similar studies for the cyclopropane derivatives shown here, for the cyclobutane derivatives of various isomeric and stereo and regular isomeric nature shown here, as well as for GAM-defluorinated derivatives shown at this slide. In this study, we also tried to analyze aqueous solubility and intrinsic clearance, and it was shown that fluorination at least does not decrease, and in some cases increase the stability, metabolic stability of the compounds. But I have no time to discuss these systems in more details here. Please refer to the corresponding publication if you would like to know more about them. And with this, I would like to thank to all people who were involved into these projects. First of all, Dr. Konstantin Melnikov, who was involved into studies of fluorinated and difluorinated cyclohexane and piperidine derivatives, and his group at enamine, of course. Alexander Grishuk and Anton Chernik, who studied cyclopropanes and cyclobutanes. Artem Skryminsky, who measured most of, if nearly all of the LogP values presented here, and Professor Dmytro Molochnuk, and many other people who were involved here. And also, I'd like to thank our sponsor. Of course, most of work was funded by enamine. We also had some financial support from Ministry of Education and Science. And also, I would like to send to non-financial support to European School of Chemistry School for Ukrainians, organized by Professor Stefan Wilke and Joanna Gosianska this summer. It was a very nice project, and I thank them very much for participating in this. And with this, I would like to thank you for your attention and for your time today. And I would like to answer your question if there are any.